Sometimes we give like a mark per column. Sometimes we give like a mark per row. It's, yeah. That's not possible. It's fine. God, why was it not possible to multiply the matrices in C? In the number. The inner numbers are not the same. Hey, we have a 2 there, and then we have a 1 over there. If they swap the order of the matrices, would I then be able to multiply them together? So this one was written first. Yeah. Then that one. Yeah. Okay. All right. D. 4 and 6.
I mean, this is the only multiplication where which way around is what's the matrix the policy of multiplication has to be? We did it in like grade.
Yeah, it's in primary school and then I never it's
The second row, first column. I don't know one. I went 20.
for E. That's 29.
Yeah.
Yeah. Sorry, no, All right, any questions? All right, there is it as well. Right, I'll post this for you after school so that you can check if you maybe made a mistake. You can look at my working maybe and double check. So, did anyone get these 6 numbers as well? No, for all of them. Okay, we are right down in your work. Are there any questions guys before we move on? Okay, we are right down in your work. That is types of matrices. Sorry about the glare here. You can just write down square matrix, don't write down the next one next. That was like my lesson prep. I wrote the stuff down, but don't write the matrix. Square matrix is the first one. Types of matrices. Let me just freeze here. So, they aren't. Not that I'm aware. Then not you what? Don't even ask the question of the smart. Okay, guys, I can't stop the whole hour. Thank you. Can we stop? Okay, so types of matrices, we just need to. I actually can't remember if we spoke about these like theoretical terminology stuff last time. I didn't write it down either, so I checked my notes. So I thought let's just all write it down. Square matrices. Oh, I handed out the page, yeah, but I didn't hand out the whole thing. Okay. So square matrices, we have actually discussed that. So let's just write it down again. Clearly we can't remember. Okay, so a square matrix is a matrix with the same number of rows and columns. For example, if you have, and now I'm actually going to move this guy down a little bit. For example, if you have 1, 2, 3, and then 7, 8, 9, and -1, 0, and 4. Okay, you can still copy this down, but do you agree that we have 3 rows and 3 columns? Right, so this is a 3 by 3 matrix, so it is a square. 2 by 2, 4 by 4, 7 by 7. Right, as long as it has the same number of rows and columns, it is defined as a square matrix. Okay, a 0 matrix. That is a matrix where all the elements are the zeros. Right? Literally 0 matrix, all the elements are zeros. I suppose we can ask what's the point of 0. Oh no. Zeros, that's with an extra E after the O, hey? Yeah, like that.
Oh, that feels wrong.
Like zeros. Zeros.
That feels very.
Sorry. I'm just sounding nice. You know what? Let's do both. Yeah, that looks more right. You can write down whichever option you prefer. That's true, yes.
But I thought it was actually possible.
No, it's fine.
I really want to know that.
It's gonna be a hard one. Okay, number 3, identity matrix. Have we looked at this? The identity matrix. So this, I'm not a matrix. A matrix where the leading diagonal, sorry, the elements of the leading diagonal are 1. All those elements are 1. That also sounds it off. But anyway. And all other elements are 0. Maybe it will make more sense if I actually draw one for you. Let's see today. Zero. Road again now. Yes, you can write once if you want. Okay, I'm just gonna write an example here. Since we are mostly gonna be working with 2 by 2 matrices in grade 10, I'm just gonna do a 2 by 2 matrix. And the leading diagonal numbers, so guys, if you had more, all of those, you know, in the leading diagonal, all of those numbers would be 1, and then all the other numbers would be 0. Now we are going to talk about this a bit more when we get to the inverse matrix. Don't stress, we just need to do something else quickly before we do that. I feel like in grade 10, there is kind of that sense of like, why are we doing a lot of these things? Same with 3. We kind of have to use grade 10 to lay the foundations, and then in grade 11 and 12, we start using all these things together. Okay, so maybe I'm going to do now the inverse matrix, and we're not going to use it that much this year, but next year and in grade 12, we can catch up. Yeah, it's going to seem a bit like, why are we doing all these things? We need to first lay the foundation before we can get into the more complicated stuff. Okay, so the determinant of a 2 by 2 matrix, I need to just teach you how to find the determinant. It's the value that we're going to calculate. So we are going to use matrices to solve equations. Like simultaneous equations. Yeah. I mean, if you do just 2 in a matrix plus another 2, you wouldn't really use it for stuff like that.
So we have to be the same. Oh,
We did that last time. It's okay.
no, but still, like, we
Okay, guys.
Yeah.
Have you copied down the pages?
Yes.
Oh.
I use.
Okay, I've moved it up a bit, so if you were done, there's some more there at the bottom here. So guys, like I said a little bit earlier, in grade 10, we're gonna mostly work with 2 by 2 matrices. So that's why this example is 2 by 2. We're only going to have to find the determinant and then the inverse, which is what we're doing next, of a 2 by 2 matrix in grade 10. Okay, so don't ask me now, how do you do it if it's a 3 by 3 and a 4 by 4? We're going to do that next year and the year after. Okay, so for this year, we are mainly focusing on 2 by 2 matrices. So this is as far as we're going to go for determinant. Okay, so like I said, the determinant is a number. You can calculate the determinant of a matrix, and this is the formula, right? AD minus BC. Maybe I'm actually going to change this highlight a bit. I'm going to do this. AD. Just finish my sentence. Okay. Minus BC, like that. Should I make it a bit darker? It's going over. Yeah. Can you guys see that?
I was wondering now,
Yes.
what is, there's a mean behind on top, and then
Yes.
two, like,
Absolutely right.
straight brackets? Does that have to do with this at all? Or is it just
No.
the lines that- When, in what context, those line brackets?
We're actually going to do this after we've done it.
Okay.
So hindsight. Soon that meme will make sense.
Understanding that. Such a-
EET, yes. 20 marks for what takes and okay, what do you think of short? Determinant. All right, guys. So are we understanding that if you have a special matrix, they're asking you to find the determinant of that matrix. What you're going to do is you're going to multiply. Are we listening? You're going to multiply the elements of the leading that add them all together, right? So A and D, those two, whatever those numbers are, might be negative, might be positive, right? You just multiply them. Then you're going to subtract the product of those two elements, all right? B and C in this case. But obviously they're going to be numbers. Again, if this product is negative, you're going to subtract the negative number, okay? Which is the same as adding a number. We'll see now. Okay. So that is what you are always going to do to find the determinant of a 2 by 2 matrix. That product minus this product. Okay. These two are just two notations for determinant. So if they're asking you to find depth of whatever the matrix is, you need to know that they're asking for the determinant. All right. They might just use the symbol instead of the words. Or if you have an A in between two, like, what is this, vertical lines? Right, and this would be the name of the matrix, right? So you noticed already that often we give matrices different names. So whatever is in between those two lines, that's the name of the matrix that you have to find the determinant. Same method, it's just a different notation. Okay, we are going to do this example quickly. It's very simple, guys. It's not like a trick. There isn't really much more to this thing than what we're going to calculate now. Just write that down quickly. Find the determinant of A, which is this matrix. What is it? Write that down, please. I can see that. Okay, so now guys, it's up to you. If they have not used a specific notation, you can decide which notation you want to use. Okay? So you can use dec of the name of the matrix, or you can use the vertical lines and the name of the matrix. Fine, it's up to you. And you wouldn't even really have to write the work down, but since this is our first example, let's write the work down. Okay, so we're going to do that product, the leading diagonal, 5 times 3. Which, like I said, I'm going to write down now, but you can literally just do it in your head. Okay. Minus, always minus, guys. It's not going to change. It's going to stay minus. The product of the other two numbers, so 4 times 1 in this case. All right, 15 minus 4 is 11. All fine? That's it. No, that's not it.
No, we just do lots of these examples.
Okay, next up. The inverse of a 2 by 2 matrix. Now guys, when they talk about the inverse, they're actually talking about the let's just say this properly. Multiplicative inverse.
Yes.
Have we ever heard that term?
Oh, yeah.
Multiplicative.
Times it becomes 1.
Yes.
Too small to
So guys, I'm thinking about something like 3 and a third. What happens if you multiply 3 and a third? What's your answer? 1.
Mm.
Now, whenever you have two numbers that when you multiply them by each other and the answer is 1, you call those two numbers multiplicative inverses of each other. Alright? So 3 and a third are, can I say it again? Multiplicative inverses of each other. Alright. So those are just in terms of numbers. Those are in terms of numbers. Now, when we're talking in terms of matrices, when you have one matrix, and when you then multiply that matrix by another one, and the answer is not 1, but the identity matrix. What did we say that was again? Right? So basically getting you a leading diagonal of all ones, yes, and zeros everywhere else. Then those matrices are inverses of each other. Okay, so I'm going to write that down. Two matrices of which the product, two matrices of which the product is the identity matrix. Yeah.
But only yeah.
You guys keep speaking to me and then I lose my train of thought. Two matrices of which the product is the identity matrix are inverses. Do I have to say of each other or inverses?
Of each other.
Of each other.
No, you don't have to. And it's the same thing there. It's just with numbers, we also have additive. Suppose it's matrix as well.
So.
Where if you're adding two things together and you get zero, yeah, I think it's zero. Then those are additive.
So 5 and minus. Wow. That sounds like a very good concept.
But it doesn't come up in matrix. So, yeah. Okay, guys. Now, finding the inverse of a matrix is, I think with numbers, it's obviously very easy, right? You can just kind of do it by inspection. What would you multiply a number by so that you get 1? All right, you can kind of do that by inspection. So if I ask you, let's think of 2 over 5. What must you multiply? What must you multiply 2 over 5 by to get an answer of 1? 5 over 2, okay? So basically the reciprocal. With matrices, obviously it's a bit more complicated because multiplication is more complicated, right? When we're doing matrix multiplication. You're doing row by column, that whole thing that we practice the other day. Okay, so it's not as straightforward as just doing it by inspection. So the method that we're going to do is, I'm going to write here, if A, and we're going to use the same kind of format, and like I said, we're just doing 2 by 2 matrices this year. So this is basically as part of the get for now. Okay, so don't worry about what happens next year. If A is this, then, and now guys, the notation for inverse is whatever the name of your matrix was to the power of -1.
Like, sorry, and that's a
Yes,
stupid
it is.
thing. But like when you think of numbers, it is.
Yeah, 3 to the -1 is a third. Yes.
Yeah.
There we go. Okay.
Yeah. Sorry, that's the
No
thing.
problem. It's fine. Okay, so now guys, and there is a whole proof, I think in the answer series, they've gone step by step, like showing the proof of it. We're not going to go through that. I don't want to confuse you guys, but you are more than welcome to look at that proof if you want. If it's not in the answer series, it is in the old textbook, so I can give it to you guys if anyone is here. All right, but in front of your matrix, you're going to put 1 over the determinant. We are going to check now that it works. Okay, we are going to have a matrix and then the inverse, and then we're going to see if we time them together, do we get the identity matrix? Okay, and then after that, now I must just remember, I think you swap these two around and you change the signs of these two. Now just hang tight, let me just double check this quickly. I think that is fine.
Yeah.
Fortunately not. Let me just double check it. Let me just double check it. Yes, it is like that. Okay. So just get my spacing right. Okay. Yeah, so this is going to be a number, right? Guys, if you remember scalar multiplication, which also sounds basic, but it's a number multiplied by a matrix, right? Go back in your books quickly. Multiplication by a scalar. Yes. So, what did we just see higher up? That the determinant is a number, right? So say the determinant is 3. You're going to put 1 over 3 in front of that number. Okay? Then you're going to take from the elements of the original matrix, you are going to swap the elements in the leading diagonal. And the other 2 elements, you're going to keep them where they are, but you're going to change both of those signs. Okay, like I said, if you want to look at the proof, please do. Alright, it is laid out very nicely. Like I said, and definitely in this old one, I don't have my answer. I can't check. And if you want, I can give it to you. It's not in the answer sheet. Okay, now guys, we're just going to do an example quickly and we're going to check that it actually works. All right, so I'm going to give you a matrix. We're going to find the inverse and then we're going to multiply the 2 together. Now, one thing that I do just have to say to you is you can leave it like this. All right, you can leave it with a third and then a bunch of numbers here. You don't have to multiply the 1 over determinant into that matrix. Okay, you can if you want to, but you can also just leave it like this. So guys, it can basically be like a two-step thing. You just quickly calculate the determinant, put 1 over, and then just do the swap and change the sign. And there you have the input. So it's not really super complicated. It's just obviously you have to remember those. Okay, so let's do an example. So if, for example, and I'm just going to make one up, and let's hope that it works nicely. Let's say that matrix M this time is 2 and 7 and 1 and 0. Okay, first thing, guys, we're going to find the determinant. Okay, so I'm going to write here, step 1. Find the determinant of M. Now we must remember our method, right? We multiply the element of the leading diagonal. So 2 times 0 is 0 minus the product of those two elements. 1 times 7 is 7. So 0 minus 7 is negative 7. Not a trick question, no? So I'll write it out again. 2 times 0 minus 1 times 7. Like I said, you can do this in your head, you can do it on the calculator if you would worry that you might lose track. So the answer there is negative 7. Okay, then step 2 is actually just going to be to write the inverse down. Okay, so we're going to say m to the negative 1 is equal to, now guys, since my determinant is negative, I'm going to do 1 over negative 7. Right? It's fine. Can I write that as negative 1 over 7? You guys okay with that? Right? 1 over negative 7 and negative 1 over 7 is the same thing. You put your brackets down. Now remember what must we do? The elements in the leading diagonal we swap. So that's going to become 0 and 2. Right? And the other two elements we leave them where they are, but we change their signs. And that is the inverse. Now I would like you guys please to calculate, do it like next to it or underneath, m multiplied by the inverse of m. Okay, that is what you're going to do now, just to check that it does actually work. Yeah, well, we hope that that will be the answer. Okay, just this once, we're going to do this, guys. You, in order to multiply the two matrices together, I do suggest that you multiply negative 1 over 7. That's it. Okay. Yes, we're just going to multiply negative 1 over 7 by each element. And then you're going to do your row by column, row by column, row by column thing. Okay, do that for me quickly, guys, please.
You're writing the answer.
Yeah.
So you go to are you writing going down or going? I don't know why I could do this
Are you
yesterday.
multiplying?
Yeah.
So you do first row multiplied by first column.
Yes. But then the first number in the first row times the first number in the second.
First column.
Yeah. Get that.
Yeah.
But then the next one times one. Do I write
So
that
now you
below it or next to it?
it depends. So if you're doing first row, second column, that gives you the number in your answers first row. Yeah. Just line it up like that.
Does anybody else have any-
Now you want, if you want to do.
Okay, let's take a look. So the second last line is the chapter, right? So from second last to answer.
One.
Then chapter.
I'm also fine with brackets the other way around.
So you multiply the numbers, but then you add the answers. On the top. So this can be a plus also because just because it was a where was it now? It was this times that. It was 0 times negative 2. Doesn't matter. Be plus. Yeah.
Yeah, but right.
All right, guys. Are there any questions on finding the inverse of an equation?
I mean, I would not why.
Yeah, so we are actually going to use this concept to solve equations. So this year we'll do that on Friday. Because we are actually going to use this still, all right? On Friday we'll do that. For now, no. For now, you are going to practice a few of these things. I'm gonna have to put it up on the board for you because again it's from the old textbook. I'm And then you guys can take a picture. Last chance, any questions? Okay. Lovely. You can label this as exercise 10.1. Or textbook. Can you guys read that? If I zoom in once, let's see.
It works with
Yeah, just hang on. Exercise 10.1, I would like you to do 2, 3, and 5. No, that's 2. 2 and 5. Yes. 2 and 5, guys, please. You get your picture? What's your way?
Very good.
And you can't see the whole top. It's here, sorry. Alright, 2 and 5. Get going now, guys.
So many teachers have lost their whole classes. So
I am. Guys, just one thing quickly. Find the inverse of each matrix where possible. There is one situation, not 2 and 5. There is one situation where you have a 2x2 matrix, but you actually can't find the inverse. You can go through all the motions, you can find the determinant, you can swap the elements, you can change the signs. What do you guys think would cause a matrix to actually not have the valid inverse when you're doing the whole process of 1 over the determinant and then swap and then that? Yeah. Yes, well done. And the determinant is 0, right? Because what are you putting in front of that matrix? 1 over the determinant. And you can't do 1 over 0. Okay. So whenever your determinant is equal to 0, you actually don't have an inverse. Okay, get going.